All right, welcome to our part 2 of the 4.7 notes. On this part, we're going to talk about our transformation rules. So if I have two lines and I want to reflect across two lines. If they're parallel, let's look at maybe a right triangle. If I wanted to reflect this right triangle across my line, the reflection should look something like that. Right, if I were to reflect that across the line, to pick up this triangle and flip it over, it would end up looking like that. Now if I were to take that same triangle and flip it across another line that's parallel to the first, it would end up looking like something like this. So here I've got two parallel lines that I reflected across, and I want to know, is there any other way that I could have gone from my first image to my final image? Is there any other transformation I could have done? Instead of flipping it twice over those lines, is there any other way that I could have moved this triangle on the left, my pre-image on the paper, all the way to my final image? So how else could I have gone from that first image to the final image instead of flipping it twice? It looks like I maybe could have just slid or translated that triangle straight across the page. So instead of flipping it once over here and getting a triangle and then flipping that triangle over again, instead of doing all of that flipping, I could just slide it straight across. And that's one of our theorems, that if lines J and K are parallel, then a reflection across one line followed by a reflection across another parallel line would be the same thing as just sliding it, just translating it across the page. So for example, this letter B, I could take that letter B and I could reflect it across two parallel lines. So maybe I'd get a letter B that looks something like, what if I can adequately trace this. I could take that letter B and I could reflect that letter B across one line, and then I could reflect it again or flip it again across another line. And if I were to reflect that twice, well, instead of doing all of that work, I could just slide that letter B, I could translate it straight across the page. So if I have parallel lines and I keep flipping over parallel lines, I could just slide my shape across. But what happens if my lines are intersecting? What if I have reflections across lines that aren't parallel, but that intersect? So let's try one example together. I've got point A, which is 4, 1, point B, which is 1, 4, and point C, which is 1, 1. So I've got this triangle right here. There we go. There's my right triangle. I want to flip that triangle first straight down. So how do I do a reflection? Well, one way that you can do a reflection is you can count up the number of spaces that your shape is away from the line of reflection, or away from the mirror if you were reflecting in a mirror. So if this first dot down here in the bottom right corner is one space above, the reflection would be one space below. The dot in the bottom left corner is one space above, so its reflection is one space straight down below the line. And my final point here is 1, 2, 3, 4 spaces above my line of reflection. So its reflection would be 1, 2, 3, 4 spaces below your line of reflection. So I could reflect it that way, right across the x-axis. Now let me see if I can reflect this across the y-axis. I'll do this in red. So I am one space to the right of that line of reflection, which means my reflection, the image, is one space on the other side. Same thing here, one space to the right, so I'll go one space to the left. And then for my final point, I have 1, 2, 3, 4 spaces to the right, so I'll go 1, 2, 3, 4 spaces to the left. So what I've done is I've reflected over two lines that are intersecting. But the question then becomes, instead of reflecting across the x-axis and then reflecting across the y-axis, is there an easier way that I could have gone from my first shape in blue to my image in red? So is there any way that I could have gone from my pre-image in blue to the image in red instead of just flipping it over the x-axis and then over the y-axis, two lines that intersect? Well, another way that I could have done that transformation, instead of flipping over the x and then the y-axis, I could have, instead of doing all of these steps, I could have just spun this or rotated this shape in blue, my pre-image, all the way over to my final shape, my image. So instead of doing all of that extra work, I could just do a rotation of 180 degrees. And that's a theorem that says that if I'm reflecting over intersecting lines, it's the same as a rotation of, and then we'd have to talk about how I could find that rotation, the degrees of rotation there. So remember, if it's parallel lines that you're reflecting over, instead of reflecting twice, you could just translate or slide this shape across the page. If you're reflecting over intersecting lines, you would need to rotate. And how do I find the degrees of that rotation? Well, the measure of that rotation would be double the measure of the angle where your first image is, your f, we call that f prime. So your first reflection ended up here, which means the degree measure that I care about is 70 degrees. And the reason why it's double is because you're reflecting once over a 70-degree intersection and then twice over a 70-degree intersection. So double the angle there, and this would be a rotation of 140 degrees. On number 8, I'm going to look for where that first image is, A prime, with just one apostrophe. There's A prime. So I started at A, I went to A prime, and then I flipped it over the line again to A double prime, or the second reflection. So the angle that I care about is the one with my first image, and that's 55 degrees. So to find my total degrees of rotation, I would double that to get 110 degrees. And finally, this one's a little bit more challenging because my A prime, my first reflection, is over here. But I don't know what this degree measure is. So how do I find that? Well, I don't know what that degree measure is, but I do know that this is 15. And if I have a straight line and a linear pair, I have 15 degrees. Well, this must be 180 minus 15. This must be the supplement, which is 165 degrees. So it's 165 degrees. And again, the angle I care about is the one with the A prime. So let me double that, and I would get 165 times 2 is 330 degrees of rotation. And if I check my drawing, that seems to make sense. Start at A, spin 330 degrees, almost a full turn, but not quite, and you would get to A double prime. Okay, why don't we try this exit slip here? I would pause the video, try to answer these three, and then unpause and check your work. All right, in our first question, what makes polygons congruent? Two polygons are congruent if and only if all corresponding parts are congruent. In a transformation, what comes first is your pre-image. That's your first shape. And then your ending point, the image you end up with, is your image. And finally, this looks like my heart shape spun a little bit, so that appears to be a rotation. All right, that's our 4.7. Check out our 4.8 videos coming out soon, and I will see you in